We did this first three slides. So let me quickly go over them. If you declare a variable as float val and assign an integer value to it, the integer will be converted to have 23 point. 23 point will be actually stored in val. The value you store in a variable has to match the data type of the variable. So if you don't match it, it'll convert the value. Same thing happens if you assign a float type number to int type variable, int size, and then if you say size equal to 23.8, you're only going to get 23 stored in it. So the fractional part will be lost. And also we discussed that we can use that sometimes to extract fractional part. So one application, let me explain that again, is to replace. So here's an example. The problem says write statements to replace the value of the variable val with the fractional part of it. So let's say val has some value in it. I'm using some example, let's say 32.64. That's what val has. Your statements will have to replace the val with 0.64, the fractional part. So here's how we can do that. We can declare another variable in type m and copy the val. So what happens now? What do we have in m? Anybody?
Shouldn't it be the 32?
It'll be 32. And now if I take the val, original value val, subtract this m, that will be 0.64. Assign that to val, then val has been replaced with the fractional part. So 0.64 goes back into val, erasing the 32.64. And that was the question. Replace the memory cell val with the fractional part of the original number. That is achieved by these two statements. Questions like this may appear in your homework or test. So remember these techniques. Sometimes the decimal point, when your variable has a value 23 point, and when you print it, it may print 23. That depends on your printing software and all that. So don't assume that the value, if it prints 23, the value is 23. It's not necessarily, it may be 23 point. The decimal point matters in C++, in any programming language. So if the number is going to have a decimal point, then you should include that in your answer. What your printout does doesn't matter. The actual value stored has to be presented as your value for that variable. So if there's a decimal point, that should be included in your answer. Okay, so let's go on to the next example. Look at this example. Float sal int num, sal equal to 34.723, and then copying sal into num. Num is an int type. Copying num back in sal again here, and then printing sal. Anybody see what will be printed exactly?
Is it 34?
34.
34 is incorrect.
Would it be the decimal?
So
Would it be like 0.723?
It's num.
not 0.723.
No.
Anyone else?
Is it num?
No, we are saying C out val. That means print the value stored in sal, print the number stored in sal. That's what it means. So it's going to print a number.
Does cell have nothing in it?
It does have something in it.
Is Sal 34.723?
No, 34.723 is wrong.
I'm so confused.
Wait, what?
34.723 is wrong. Let me go through this. 34.723 is stored in sal. and sal is float type, so that's going to be fine. That's going to be stored as is. But then num is int type. When you copy the sal into num, what are you going to get in num?
34.
34. So num has 34. So num has 34, and when I copy the 34 into sal, it'll be 34 point. You understand?
Well, I thought someone answered 34.
Num is 34, but sal is a flow type. So when I copy the num into sal again here, that's going to be 34 point. The sal is flow type, so it can only hold flow type values. So the decimal point will be added to make it float. And so,
Even Professor, even if it has no numbers apart from it, it would just show the period.
yes,
Okay.
period is part of the answer. That's the point. Okay, the decimal point. So if I ask you, if I give you this in your homework and ask you what is the output or what will be written on the screen, that's 34 point. If you miss the point, it's wrong answer. Okay, the point is necessary.
So the output's always going to be like the whole number. It's going to be the number and then just the period after it. That would be like the answer.
Yeah, if it is a whole
Alright.
number, it's a flow type number, but its whole number means 34 point is going to be there. The point is going to be there.
Okay.
But when we write something like that, normally we write 34.0. Otherwise, the point can be missed. So normally, when there's a decimal point to highlight it, we write a 0. So you can write a 0 behind it like this. That'll be even better. But if the point is missing, if you write 34, that's incorrect answer. Okay, 34 is not right. 34 point is the right answer. Okay, moving on. So what if you're converting between character and integer? We learned in the last section, when we learned ASCII codes, that characters, alphabets A, B, C, D correspond to numbers. A corresponds to 65. B, capital B corresponds to 66. C is 67, all the way to Z being 90. Those are the numbers, equivalent numbers to the characters. Similarly, lowercase alphabet A corresponds to 97, all the way to Z. Lowercase z is 122. So these codes, the corresponding decimal codes, you will need to answer some of these questions. So when you're doing homework, you can look up the full detail of these codes are there in the appendix A. But if it is test question, I had to give you those codes. It'll be given at the beginning of the test. Anyway, if you convert an alphabet like A to integer, it'll become 65. A and 65 are equivalent. If you remember from last section, the ASCII code of A and the binary code of 65 are same. So when you stored A in the memory or when you store 65 in the memory looks the same. So does the system know what you stored? No, it doesn't. The programmer has to know in what form he or she wants the answer come out of there. So if you store an A in an int type variable, you're storing 65. And if you print it, you're printing 65. And similarly, if you're storing 65 in a character type variable, you'll get A stored in it. And when you print it, it'll be A. So it's all based on the type of the variable, not the original value you stored. So original value was 65, but the type is character. So it'll be converted to character. And when you print it, it'll be character. Assignment, when you do assignment with these alphabets, you're converting them accordingly. So here's an example. Val2 is an int type variable that has 65. And now I'm copying the val2 into val1, but val1 is char. So 65 is converted to character. So val1 has an A. So when you print, you're printing A. The output will be A. So here's another example. Num1 is int, and ch1 is a character type variable, and I'm storing B in it, character B in it. Then I'm actually copying ch1 into num1. Num1 equal to ch1. Num1 is int. So the B will be converted to integer, which is 66. And so cout num1 will print 66. This assignment statement right here is doing a conversion. We say that this is a conversion in assignment. Same thing here, conversion in assignment. Here we are converting from integer to character. Here we are converting character to integer. So such conversions will happen. Okay, so let's do some exercise now. Determine exactly what will be printed for each of this. Anybody has an answer for part A?
Would it be 32 point?
No,
It'll be
It will
just
be
32.
32.
Just 32.
just 32 is correct. N1 is integer type, so it'll pick up only 32. So only 32 will be printed. Part B, anybody has an answer?
It'll be
5
5
point.
point.
5 point is right. Part C has a division 7.0 divided by 2.0. That division will be 3.5. What will be printed?
3.5.
3.5.
Yes. Part D,
99.
99 is what we are storing, but what will be printed?
99 point.
No,
A.
It's like a lowercase, I think, what is it?
Lowercase a.
It's
I mean,
it's C. It's
Is it
C.
a letter?
Lowercase c.
Lowercase c.
lowercase c is correct. Because we are converting 99 to char. You see that, right? So remember I said 97 is A. I'm writing on the board now. 98 is lowercase b. 99 is lowercase c. So when you convert 99 to lowercase alphabet, to an alphabet or to a character, it'll be C. So you're printing C here. Okay, part E, 25.8 divided by 3 will be 8.6. The division will produce 8.6. What will be printed by the program?
Would it be 8?
8 will be correct. Because this division will be correctly done, it'll produce 8.6, but then when you assign it to n, you're storing only 8.
Professor, I got a question.
Yeah.
So what happens between like 96 to 95 in like the letter thing? Because it skips from 90 to 97. Is there like any symbols that represent that?
Yes, those numbers correspond to some other symbols other than alphabets. Okay. All the numbers from 1 to 255 correspond to some symbols in the that we use. You know, even plus symbol is coded. It has an ASCII code, right? So there's a decimal equivalent for the plus symbol. There's a decimal equivalent for the slash. So every symbol we use has a decimal code. And so this 90 to between 90 and 97, those numbers correspond to some other characters. We don't need to know. Okay.
Okay, perfect. Thank you.
All right. Yeah, feel free to ask the questions. That was a good question. You know, you do need to understand that. All right, moving on. Applications of data conversion. So these conversions that we learned sometimes are useful. So I'm going to give you some example. Suppose that you want to do some division, but you don't want the entire answer. You only want the integer part, the whole number part as answer. So you store the numbers, float type numbers, 7.2, 46.5, both of them in float type variables. You do the division, so division will be done right. then the result you store in an int type variable. That will pick up only the fractional part. I mean, the integer part, the whole number part. You print that, then you're only printing whole number part. And so things like that are some applications. You know, you can replace, you can just get the answer exactly how you like it. You don't want the fractional part, then you can do it. So these are, that's one of the applications. Another application, this is more important application, is rounding a number. When your system produces an answer, if the answer has 15 decimal digits, it's going to give you all of that. Your answer may appear as a long fractional number, like this, you know, 4.7 6, 3, 2, 1, 5, 7. All those digits are going to appear in the answer. So sometimes we don't want them. We just want either this one fractional digit or 2 fractional digits. That means we need to round the number to 10th. This is the 10th digit, or round the number to 100th. So we want to round the number. I mean, the system doesn't know how to round, so it's not going to give you any rounded number. You have to write your statements to round the number. So the technique for rounding is what I'm going to explain next, rounding. So let's start with, so the technique is to use these conversions that we have learned. So I'm going to first explain rounding to the nearest integer, Okay, so let's say the number, if the original number stored in the variable val is 4.7, then the nearest rounded integer will be 5. If the val has a 4.4, something like 4.4, the rounded number will be 4. So whatever technique you're using will have to work in both cases. So here's the technique. You just add a 0.5. You take val and add 0.5 to it. Okay, so what happens if you add 0.5 to this number? It'll become 5.2. If it is this number that you have in val, then it'll become just 4.9. And if you take the integer part, after adding it, you take the integer part of it, that'll pick up 5. Here, the integer part is 4. So the new number is the rounded number. So basically, the rounding technique is to add 0.5 and then take integer part. So all you have to do is declare int type m and assign val plus 0.5. You have rounded number going into m. Any questions so far? The value stored in val is now rounded, and the new rounded number goes into m. You do that if you want to put the rounded number somewhere else. If the problem says replace val with the rounded number, then you still have to do this step and then copy m into val. Then the val now has rounded number, but it will have a decimal point added to it. Val is float type, so therefore it will not be an integer number. You'll be storing a float type number. So it's a whole number with a decimal point added. That'll be still a whole number. So your number is rounded. If you're rounding the number and storing somewhere else, then this is the answer. If you're rounding the number, putting back in val, then you had to write both of these. Then val will have the rounded number. Everybody's good? Any question on that? Okay, then I'm going to do one more example. Round, this one is to round to nearest 10th. So now we want to round at the 10th digit. So let's use some example numbers. So if the number is 4.76 and other digits are there, then the rounded number will have to be 4.8. We're rounding right here. It'll be 4.8. If the original number is 4.74, the rounded number will be 4.7. So whatever the technique we use has to work in both cases. Okay, so what's the technique? The technique is the same thing, adding 0.5, but this time I have to do something else first. I will multiply by 10 so that it'll become 47.6. I move the decimal point over to make it 47.6. So in this case, it'll become 47.4. Now add 0.5. Add 0.5. That will make it 48.1 in this case. And if you add 0.5 here, it'll be 47.9. Now you take integer part. All right. Take integer part. That'll be 48, which is your round, which is rounded at that digit. Here it's 47, but I have to bring it back to the original. I have to bring back the decimal point. I moved the decimal point over by multiplying by 10. And then I did all this process. So my number is 48 now. I have to divide by 10 to make it 4.8. I have to move the decimal point back. So same thing here, divide by 10, you'll get 4.7. So I'm going to now write the statements to achieve that. If you understood the process, then you will understand the statements. So what I do is, the val has the number. We don't know what value is there. So I take the val and multiply it by 10. So val equal to val equal to val times 10. So that is to move the decimal point over. After that, I need to divide by, I need to add 0.5. So to the val, I add 0.5. So that's like 48.1. And now I have to take integer part to drop the 0.1. So assign it to integer variable m. So now you add 0.5 and then assign to integer variable. So we did this process, multiplying by 10 and then adding 0.5. So now the number is this. And from that number, I need to drop the fractional part. And that's what I did by assigning it to integer. So now I have this number in my m. And I need to divide by 10 to bring back the decimal point. So take the m and divide by 10.0. I have to divide by 10.0 and you will see why later. And assign it back to val. Now val has the rounded number. Val has the number rounded to nearest 10th after this process. It's no matter what value was there originally, it's been rounded to the nearest 10th. Any question? Okay. Now that's one of the applications. Okay, the exercise says, okay, well, hold on a second, just to make this.
Professor, can you make the slide bigger? I can't see or understand. Yeah, I can't see the slide.
Slide here.
Yeah, I can't see anything for it.
You probably have a smaller screen then.
No, I have a laptop, but like it, yeah, it's really hard to understand.
Okay. Is that better?
Yeah, thank you.
All right. Then I have to keep switching between the two, but it's all right. The warm-up exercise here says, write C++ statements to extract and print the first digit of a 2-digit number stored in the variable m. So m has 2-digit number. we need to print the first digit. Okay, anybody can tell me what to do? It has two-digit number. We need to get the first digit printed.
So would we divide the integer by 10?
10, okay. If the number is like 75, now you have 7.5.
Right. So it would become integer. And then
That's not integer. So what do you want to do
I'm
with it?
sorry, not integer, float.
Yes. What do you want to do next with it?
Then when we add 0.5 to 0.5 to it, so we get 8.
No, we would just make it an integer so it would drop the point.
Right.
That's what I meant to say.
Exactly. Adding 0.5 would be correct only if the original number is 7.5. We don't know what number is there.
Okay, all right.
So to take the 7 out of it, you need to take the integer part. So whatever the number is, if you divide by 10 and then take integer part, that'll give you the first digit, right? So let me write the statements.
First, I just have a quick question.
Yeah.
So what you were saying was, so if the number is like a whole number, you're basically just going to divide it by 10, and then whatever your answer is, you're just going to drop the decimal point. So like what you said, 75, you divide by 10, you get 7.5, and then you're just going to drop the decimal right from there, and that'll be your answer.
Then it'll be 7. That's your answer. Yes.
Okay. All right.
All right.
All right.
So if the number is, yes, someone just came in. Hold on. Okay, so if the original number is 75, you divide by 10.
Try to make that the regular computer turn on first and then do it from there. Turn on that computer. Try to make it only from that one. Stop.
You talking to me or someone else?
Oh, sorry.
If you're not talking to anybody, talking to us, then you can turn off the microphone. 75 over 10 will become 7.5. And if I take integer part of it, that'll be 7. That's how I can isolate the first digit. So here's the statement then. If the original number is in M, then take M and divide by 10 and assign it to integer variable n. Now n has the first digit of that number. Okay, divide by 10 and assign it to integer. All right, moving on. The operators, we learned these operators before. Addition will be plus, subtraction will be minus, multiplication will be asterisk, division will be slash. So these are the only operators we have learned. Now there's a new operator we are going to learn, modulus, in a few minutes. Before that, let's look at this example. If I want to write a program that'll compute x squared plus 2x for the value of x equal to 3, then, and print the answer on the screen, that'll be x equal to 3, int x equal to 3, and then float x squared plus 2x. X squared has to be written as x times x, and then 2x has to be written as 2 times x, and then assign that to y, and then see out y. The value that will be printed by this will be 15 points.
Professor, quick
yeah.
question.
Yeah.
Does the computer follow PEMDAS?
Follow what?
Order of operation?
Yeah, order of operation. Oh yes, that's coming up later. We are going to discuss that.
Okay.
There is an order for the operations. So it'll print the answer as 15 point. And so I made the point already, you had to present the answer as 15 point, not as 15 when it is a float number. So let's understand the modulus operator now. The modulus operator is applicable for integer numbers. And if you operate modulus operator between 23 and 5, for example, you're finding the remainder of dividing 23 by 5. That's the meaning of that. If you divide 23 by 5, it goes into 25 goes into 23 4 times, but 5 times 4 is 20, so there's a remainder of 3. That 3 is what the value of this operation is. The value of this operation is the 3. That's what it produces. So here's an example. Int m equal to 23, n equal to 5, and k is another integer variable. K equal to m modulus n, then k will have a 3. See out k, you're printing 3. So that's what the modulus does. It gives you the remainder of the division. And remember, it only applies to integers. If you use it with fractional numbers, it'll give you error message. The compiler will reject it. The result of 35 modulus 2 is 1. 1 goes into 35 17 times with the remainder of 1. 34 modulus 2 is 0 because remainder is 0. 2 divides 34, answer is 17 and no remainder. If you have multiple operation of modulus like this, then it has to do them in an order. If you have parentheses, then it'll do the first one first, the one in the parentheses first. 17 modulus 10 will be equal to what? What is that equal to? Anyone?
Wouldn't it be remainder 7?
Remainder of dividing by 10. And what is that?
7.
Remainder 7.
It's 7. 10 goes into 17 one times. Remainder is 7. So this expression is equal to 7. And if you do modulus 4 with that, then 7 modulus 4 is basically what you're doing. And the answer is 3. 4 goes into 7 one time with the remainder of 3. Okay, so here's a warm-up exercise. Can you figure out the output of this program?
Is it 1?
Output will be 1. That's right. Very good. That's because A modulus B is 33 modulus 7. 7 goes into 33 4 times, but 4 times 7 is 28. So the remainder is 5. The value of A modulus B is 5. So now we are doing 5 modulus 2. 2 goes into 5 2 times, remainder is 1. So D has a 1, and that's what you're printing. Okay, so modulus operator is there in the computer programming language because it is useful for a variety of different things. One of them is to determine whether a number stored in a variable is even or odd. So for example, if n is odd, is even number, then even number divided by 2 will have 0 remainder. So by looking at n modulus 2, if it is 0, then n is even. If n modulus 2 is not 0, it'll be actually 1 if it is not 0. Because when you divide by 2, the remainder has to be 0 or 1. So if n modulus 2 is a 1, then n is odd. So it is useful to decide whether n is even or odd. Now, we are not ready to write program using this kind of operation yet. Only after we go to chapter 3, we'll start using these ideas. Now, extracting last digit is another application of this operator. So let me go to the board and show you an example. If I want to find, let's take an example of 87. And if I take modulus with 10, what is the value? What is the value of this operation?
Is it 7?
7. Okay, 296 modulus 10. What would that be?
Wouldn't it be 6?
6.
Be 6. Can you see that? It always gives you the last digit of the number?
Yeah.
Right.
Yeah, I see that now. Yeah.
Yes. So by taking modulus 10, you can find last digit of any integer. Okay, can somebody tell me how can I get last 2 digits, 96?
I would
Modulus
I'm
100.
Say again?
Is it modulus 100?
Modulus 100, that's right. If you divide 296 by 100, 100 will go into 296 2 times with the remainder of 96, right? So that's the technique for getting digits separated from numbers. Getting digits separated from numbers is necessary in computer programming. That's the technique. So let's see the exercise. Yeah, the exercise says, write C++ statements to extract and print the second digit from last. So that would be, if the number is 296, we want 9, second digit from last.
So when you get the modulus of the 100, it would be 96. Then you could divide it by 10.
To get the 9, yes.
Get
And
the
right, you got it.
get an integer.
If the variable m has the value, the first thing you need to do is modulus 100. So I can write in several steps. Mendoza. Let me write it in right by step. Whatever the m is, m is an integer. Only for integers the modulus operator can be used. So first thing I want to do is take modulus 100. So m modulus 100 will give you the last 2 digits. And now you divide by 10, divide that by 10. That'll give you a fractional number. You have to divide by 10.0, by the way, to get the fractional number. But just dividing by 10 will also work. So basically, if it is 296, then taking this modulus 100 will produce 96. And then when I divide by 10, I'm making 9.6, and I need to pick up the integer part of it. So assign it to integer variable m. Now m has the 9. You do that if it is okay to erase the original value of m. If it is not okay to erase the original value of m, then instead of m, you use another variable in type, n. Then now n has the digit before last. Okay, so modulus 100 and then divide by 10. So by combining these modulus and dividing and taking integer part, all that, we can achieve anything with the digits. And so questions like that will be there in your homework and test. So you have to figure out what operations you have to do in what order to achieve that. So basically these are the ones, modulus and division. Okay, so moving on, the memory allocations. When you declare a variable as char, you're saying that you're going to store a character value in it. So for storing character values, you know that only 1 byte is needed. We learned that in chapter 1. Every character is coded using 8 bits. 8-bit memory is called 1 byte. So to store a character in the memory, you need 1 byte of memory. So therefore, any variable declared as char type will only get 1 byte of memory allocated for it. If you declare a variable as int type, then the memory cell you get for that variable will have 4 byte long memory cell. Float also gets 4 bytes. That's because numbers can be very large, so it allows large memory to store the number. We need to understand which data type is bigger than which, because in the next, our next topic is conversions in arithmetic operations. The conversion will be done based on which is larger type. So a larger type means the data type that gets larger amount of memory. So between int and char, clearly int is larger. It gets larger memory. Between int and float, even though they get same amount of memory, the float is considered to be larger type. So you just have to remember that float is larger than int. But int is larger than char is clear. So the next thing is conversion in arithmetic operation. Okay, so let me explain this idea first. What we need to understand here is the system, you know, the computer can only go with certain rules. It cannot change rules according to the situation. Now, when we humans do our arithmetic calculation, we can understand what type of answer we will get for each different situation, and we adjust to that. But the computer has to be instructed as to how to process the numbers, and it can only go by one set of instructions. It cannot change it for different situations. So what I'm talking about is this. When I ask the system to multiply two numbers, if the two numbers are both integers, when I ask the system to multiply two numbers, I have to tell the system ahead of time what type of answer is expected so that it can store the answer somewhere. There's this, every time it does the calculation, it has to store the answer somewhere, or it has to do the calculation somewhere. And that area has to be a certain type, and it needs to know what the type that is. In other words, it needs to know what type of answer is expected ahead of time before the operation is carried out. So if the two numbers are going to be integers like 5 and 2, then we know that the result will be integer. So the computer has been instructed that. If both are integers, the result will be integer. If both are float type numbers, then clearly the result will be float type, so the result will be float type. Computer has been instructed that. If they are mixed type, like 3.5 and 2, one is float, one is int. Okay, which is the right type to have for the answer? Sometimes the answer can be whole number. In this case, the answer is whole number. Sometimes the answer is float number, right, with fractional part. So it is safe to say the answer will be float type. Wouldn't you agree? So if you make the answer float type, even when the answer is whole number like this, the answer will have a decimal point with it. That's no harm done there. If the answer is going to be, if it's 3.4 times 2, something like that, then the answer is now 6.8. It has a fractional part. So sometimes there's fractional part, sometimes there's no fractional part, but it is safe. We can only go with one rule. When the operands are two different types, when the operands are same type, then the answer will be same type. If the operands are two different types, when which type should be the answer? It's safe to say the answer should be float. Agree with that? Only then your answer will come out right. If you say the answer will be integer type, clearly in this case, the answer is going to come out wrong, right? So therefore, it's safe to make the answer float. So therefore, the system has been instructed this. If both operands are of same type, the answer will be same type. If the operands are mixed type, then convert them both to larger type, which is in this case float, and produce an answer which is float type. So if you ask the system to multiply 3.4 by 2. If you write this expression in this way, you will actually convert them both to float, 3.4 times 2.0, and then it will multiply and get you 6.8. That's because it is instructed to do that. If both are different type, convert them both to the larger type, and then carry out the operation. That operation can be anything. I'm using multiplication here, but addition, subtraction, multiplication, division, for all those operations, this is the process. If the data, both operands are of same type, the answer will be of the same type. If they are mixed type, then convert both to the larger type and answer will be larger type. So that's the rule. And it is written right here in the box at the bottom of the screen. If the operands are float and int, then convert them both to float and produce float type answer. That's the instruction it goes with. And with that instruction, all the operations work right, almost all of them. You can see that this operation will be working right. It'll produce 6.8 correctly. And 3.5 times 2 will produce 7.0. The answer is 7. It'll have a point. That's no problem. Still, the answer is right. So at least we are getting the right answer. So with this rule, the arithmetic operations are working fine. So you have to remember this rule. This is the rule it's going to go by. When you do that, when you go with that rule, there is one problem. The problem is the division. If you are dividing a fractional number by a fractional number, there's no problem. You know, if you're dividing 5.2 by 3, then this is float, that is int. It'll convert both to float. So it'll do 5.2 divided by 3.0, and the answer will be right. So no problem there. So all operations work fine. Only when you divide integer by integer, 5 divided by 2, we have a problem. Why? They're both integers, and therefore it'll recognize the answer as integer type. So even though correct answer is 2.5, it's only going to give you 2, because that's the rule it knows. Both are integers, so the answer will be integer. Similarly, if you divide 2 over 5, 2 over 5 is, correct answer is 0.4, but it's going to give you 0. So division is a problem. So with this rule that the system is using, all the operations are going to be right. The division is not going to be right. So let's understand that a little more. So here is the example. Float m equal to 5, int n equal to 2. If you make one of them float, m float, then you can get the right answer, right? That's one correction, one way to correct that problem. If you declare m and n as integer, like I did in the previous example, sorry, yeah, in this example, int m equal to 5, n equal to 2, and then I write m over n, that's going to come out wrong. So how do I correct that mistake? One way is to declare one of them as float. The other one can be still int, and then do the division. And you have to declare the s also, the answer variable for the answer as also float. Then that'll work right. You can also declare both of them as float. You don't have to have 5 and 2 as integer. If you declare them as float, then m has a 5 point, and then n has a 2 point, and if you divide them, it'll be 2.5. The s has to be also float. So if s is float, this will produce the correct answer, s equal to m over n. It'll produce 2.5. What if I declare s as integer? Now this m over n, what is the result of this division? Just look at the division. What is the result of that?
2.
No, m and n are float. M and n are float, so m has a 5.0, n has a 2.0. 5.0 divided by 2.0 is going to be what? It's not 2.
5.
2.5.
0.5.
2.5. Only if you divide integer by integer, you will get integer answer. Right now, M and N are float. They're both float numbers, so 5.0 and 2.0. So the result of this will be 2.5. What will be stored in S?
2.
2, because S is integer type. So that's a different problem. That's a conversion in the assignment. So what you need to pay attention to is conversion in the operation. Conversion can happen in the operation, and conversion can happen in the assignment also. These are two different things. You have to do this operation first and get the value. Then you assign it to S, do the operation, do the conversion that will happen in the assignment. That'll be the last step. But whether S is float or int doesn't matter for this division. This division will depend on whether M is float and N is float or not. Here, M and N are float, so the answer for this division is 2.5. And when you assign it to S, it'll pick up 2. Okay, so the warm-up exercise. What is stored in S is the question here.
It's gonna be 4.5.
4.5 is wrong.
Is it just 4
4 is wrong.
or 4 point?
4 point is correct.
Good.
All right, let me go over that. M is an integer variable, so 9 will be stored as 9. N is integer variables, 2 is stored as 2. Here you're dividing integer by integer, so it'll produce 4 as answer, integer answer. When you assign it to S, the 4 will be converted to 4 point. So SS 4 point, okay? It looks like very simple example, but there is so much you have to pay attention to. And you need to do that in your homework problems. Okay, so let's, let me give you some more examples on the board to clarify this. Even if you don't use variables like this, let's say I'm writing a program. Okay, let's do that here. The 9/2 here, let's say I write it as float W equal to 9/2. Okay, what would be stored in W?
4.5.
No, that's the point I'm making. Because you have a division here, right? And the division has integer divided by integer. So the result of this division is 4, not 4.5. And then when you assign it to W, W will pick up 4 point because W is float. So the actual value stored in W is 4.0 or 4 point.
So if there was a decimal in the 9 or the 2, then it would be 4.5.
Right, exactly. So that's what you need to pay attention to. If you're writing 9, if you need to do 9/2 in your program, make it 9./2 or 9./2 point is also okay. One of them has to be float. If one of them is float, then the whole thing will come out right. So that's what this whole discussion is for, to make sure that the answer will come out right. You may have to add a point to the number. Okay, so float x and then x equal to 17.5. This is not going to store the right number, the correct answer, because 17/5 is not going to be the correct value. 17/5 will produce only 3. And when you assign it to x, it'll be 3.0. So the correct answer is 3.4. To get that correctly done, you need to add that decimal point. either to the 5 or to the 17, one of them. So whenever you are doing a division, if you expect the answer to be float type answer, fractional answer, then make sure the operands have at least one of them float in the division. Only then the answer will come out right. Okay, so let me see if you can do these and then tell me the answer. For the exercise 4, what will be printed?
Should it be 2.5?
2.5 is right. This program will work properly because n is declared as float, and therefore the division will be correctly done. Okay, the second one, m doesn't have a value, n is 3, a is 4.6. A plus n over 2 goes into b, a plus n over 2 goes into m. So what will be printed is the question. Since a is float, a plus n will be float, right? Remember, if one of the value is float, then the entire
That-
will be float, right?
That first one, isn't it 3.8? Where b equals a plus n divided by 2, wouldn't that be 3.8?
That's right. So b will be 3.8. So b will have the right number for the division, yes.
And then m would be 3 point, because since m is an integer. Oh no, because a is also a float, so it would also be 3.8 as well.
No, the b is float, so b will have 3.4 correctly stored. The m is integer, so the number produced by the right side will be converted to integer. So 3.4 will be converted to integer, so m will have 3, not 3 point. Okay,
Isn't it 3.8, not 3.4?
3.8, sorry, yeah. 3.8. So b will have the 3.8 correctly stored. M will have 3 stored. Okay. C equal to n over 2. So n is 3. And so what will you have in C?
1.5.
No.
It
Is
should
it
be
just
1
1 point?
point.
1 point. That's right. Because this division will produce only a 1. Because n and 2 are both integers. That's a 1, and when you assign it to C, it'll become 1 point. Okay. All right, so the cast operators. Okay, even though we have few minutes, I have to keep the two classes matching, so therefore I'm going to have to stop here.